Hey everybody, this is Larry. This is me doing day 24, the day before Christmas. Leetcode Daily Challenge. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about today's problem. I'm still in Panama City. I'm just on the couch right now instead of on the weird high table. So we'll see if this is better. Let me know what you think. Today's problem is merge intervals. Okay, so this is kind of a standard problem by now, or at least variations of it. Merge in this case is a union. Is it right? Yeah. So yeah, that's pretty much it. The way that I usually solve these is by sweep line. There are definitely ways you can do this in a pretty straightforward way. I don't know if these are in increasing order. They do not appear to be. So it does look like it in the examples. So the way that I usually do it is with sweep line, though you can always sort and then do something funky. But that's the way I'm going to do it. So that's the way I'm going to show you. So the way that I set it up is just all these events, and then now for start and end and intervals, we have two events, right? We have two type of events. One is the start event, and then let's just say this is +1. And then an end event. This one is, I think this one is sometimes you have to be a little bit careful on. It's very tempting to write this instinctively without thinking about it, especially without our experience. But it really depends on how you want to handle the edge cases. In this case, for example, let's say you have, 1, 5, and then 5, 6, right? Or 5, 7, doesn't matter, right? You want to merge this to 1, 7. Where in some cases, in this case, because we're talking about the endpoints of an interval, that may work, but sometimes you're talking about boxes and you're talking about index boxes or something like that. And there you may have to be careful as well, or sometimes you just don't want the endpoints to count as intersection, right? So there are a lot of different nuances there. I think in this case, this is maybe okay. Okay, the way that I actually want to do it is then now make it exclusive, right? So then now we want our endpoints to be exclusive and starting points to be inclusive. The reason is just so that if we have, like, for example, let's say we have this event, the reason why we set it up for e -1 is so that we have 1, 5, and then but then we set this up as 6 technically. So that means that the 5 event will happen before the 6, right? So now you have start of 1, start of the other 5 from the second interval, and then end of 6, and then end of 8. So then this way, you kind of start these off, and then you do the intersection that way. And of course, at the end, you'll have to make sure that you know that this is an exclusive bound. So as long as you do that, it should be fine. Okay, so then now given this, we can have event.sort. We just sort this, and then I kind of hand waved over the merging part, but here how do we rephrase this problem in terms of for merging, right? For this problem for merging, what we want to say is that any area that contains one or more intervals, we want to count them, right? So here again, I'm going to use some ASCII art. So for example, you have this thing, you have this other thing, you have this other interval. And the way that the way that you could think about it is that, okay, here there's one interval, 1, 1, 1, 2, 2, 2, 2, 1, 1, 1, 1, 1. Maybe I'm off by 1, but let's say later you have another interval here. Then of course you would have 0, 0, 0, and then 1, 1, 1, 1, 1, 1 again, right? So of course, then now you just have to combine all the non-zeros, and that's basically the idea behind this one. And of course, this is the union. So while this picture doesn't change, how you construct the new intervals might, if you're given a variation of this problem, right? For example, if you're given an intersection where you only care about things that appear in multiple intervals or something like that, depending on how it's structured, then maybe you want the ones that only have 2, for example, right? instead of non-zero. Or if you have 3 intervals and you want only 2 or higher or something like that, I don't know, some weird funkiness, right? Like depending on the problem, then you could do that with this experience as well. And of course, the events that will happen, the way that we gauge it is, of course, at these critical events where the numbers change, right? Kind of. And this, of course, matches the beginning and the end of these arrows. We're off by 1 aside, but that's from the drawing. Okay, so then now, now we can start processing the events, right? So then now we have 4. So we have, I don't know, the sweep line X, and then the actual Y for event in events, or this is more like type. Though in this type you can actually have, you can make this a enum if you like, if you have multiple things that you want to process in different ways. But the way that I structured this a little bit is a little bit with the concept of prefix sum, in that all I have to do is just add t. So now I have a current interval is equal to 0. We start with 0 because if you think about this, to the left of this is going to be 0, zeros, right, before the actual start. So then now we add the t. And again, if current is, so what are the events that we care about, right? Because we only care about the non-zeros. There are only 2 types of events we care about, from a 0 to a 1 and from a 1 to a 0, right? So you could code this in a different way, but it doesn't really matter, right? As long as you kind of keep track of these, which is that, the previously this is 0 and then now it is 1. So there are a couple of ways you can say it. So for example, if current is equal to 1 and t is equal to 1, that means of course previous is equal to 0. Then start is equal to x, say. And of course this only happens at the beginning, right? So you have to make sure that your condition is true. And then else if the other condition is from 1 to 0, but of course that I think current is equal to 0 suffice because there's no other way to get to there. Then you have n is equal to x minus 1 because again, in this case, this is an exclusive bound. And of course, you know that the t event is an n interval event because again, there's no way to do 1 to 0. But of course, you can be you could be more explicit if you like. I'm a little bit shorthanding it a little bit because you can skip ahead a little bit. But again, for different sweep line algorithms, you might have different enums that match different events in a more precise way, right? So then, okay, so this is the end. And of course, the end, now we have a list of intervals that we could care about. Arguments could call ends for answer. So then here we can have ends dot append start n, and the start is equal to none again, though technically it's not necessary, but I like to clear it up. And then we could just return ends at the end, noting that we always have I didn't draw it out here, but we always have a event at the end as well, right? So that means that this is going to have zeros at the end, though technically we'll stop parsing here. So that means that this will always happen. If whatever your condition is doesn't have that, then if your scenario doesn't have that, then you might have to add some special cases after the loop, but this should be good conceptually. So let's give it a spin. Let's okay. These are kind of crappy test cases, to be honest. I mean it's good, but that's because the cases are kind of crappy. I don't know. Let's do another one. Let's pretend, for example, 3 and 9. I don't know. I guess it doesn't really matter. We'll give it a submit real quick, just because I'm a little bit lazy today about testing, but perhaps you should test. I did it twice before apparently, and the third time is still a charm, and we have a completion streak of 633 days. So what is the complexity of this algorithm, right? This is going to be n log n because we have n 2 times n event, and the sorting becomes n log n, and of course this is just a linear loop with O of n space, but that space, of course, is used both in events and also the answer, so it's kind of output sensitive. So n log n time, O of n space, and that's pretty much all I have for this one. Let me know what you think. Yeah, that's what I have. Stay good, stay healthy, to good mental health. Let me know what you think. I'll see you later and happy holidays. Bye bye.